Okay guys, so today's job is to repair this axle for press, an eccentric press. All the bearings were shot. The bronze, it's very worn. It's a very poor quality bronze. It's too yellow to be a good bearing surface. The connecting rod is already bushed, and we need to turn down the steel bushings because we replace them because it's cheaper to replace the steel bushings on the shaft than to replace the bronze on the caps. This is how we started. We just machined the diameter down in the connecting rod and pressed it in and rebored it to size. On the caps, we need indicated in for the chuck. We use some small machinist jacks that I made. They are pretty handy, and they are work fine for this kind of application, and they are get to use the most in the shop. So for indicated in diameter, we split between 180 jaws because we have 0.05 millimeters out of roundness on this part. Maybe it's worn, but we split it and turned out great. So the indicating in went smoothly. This is the machinist jacks, just some nuts and bolts. We machined the interior until it was clean, and after that we machined the steel bushings to grind in this surface. So the old was 126 millimeters. The new, after turning, it's 131 millimeters. So it was a lot of wear, and if you see, there are a couple of spots that didn't quite turn down. For indicated the shaft, I need to use a counterbalance, and this pretty good balanced like this. We needed to uh, hold by the thread. It's not the best way to hold it, but I put some brass stock between the jaws and didn't damage the threads. It's not the first time that I do this job. The company has a couple of presses, and each year basically brings a press with the eccentrics to reclaim them. It's not an unusual thing for me to do it like this, and never had a problem to destroy the threads by holding it like this. We hold it not that tight. We machine with not crazy feeds. Basically, we do just finishing cuts to the diameter that we seen before, so they can run smoothly. After turning, I use some emery and polish the surfaces so we don't have any machine marks. Basically, don't have any cutting marks from the lathe work because the lathe always basically machines a small thread. So we need to remove all the high spots to make it even so we don't wear the bushing. You cannot just turn a part. Uh, doesn't matter how the turning is done. You cannot just turn the part and put it in a bushing, and so it will spin in a bushing. It will destroy the bushing much faster than if you polish the part, because now we have a small thread because you are using the feed, and it's not good for the bushings. Yes, ideally you can ground this diameter, but I don't have the grinding machine to be capable to grind this eccentric. Basically, you need a cam grinding machine that I don't have. Here I machine the crankshaft, and my father is watching, so I don't crash the lathe. But I will stop the machine. He just brings me the attention that we need to stop it so that we don't crash the machine. Now we make the chamfers on this large bushings on large crankshaft. I switched the tool from the inside boring tool with a tool that is ground to 45 degrees to make the 45-degree chamfer on the edge, and after that I flip the part and do the 45-degree chamfer on the other side so it can slide easily on the eccentric on the shaft. To be a good alloy for the bushings, we need to have a copper thin alloy, and that is more red, so it's like the bushings that I put in the machine. The more yellow it is, it's not great bearing surface. So my bronze, it's way better for this application that the bronze that originally was in this machine. And this is the tool, and we finished the job, so we send it out to the customer. And that's it. Bye.